Welcome to this video on climate risk and critical infrastructure. This has been brought to you by the Climate Risk Institute. This project is being implemented by the Climate Risk Institute, a Canadian non-profit organization who focuses on climate adaptation and resilience. The activities are part of the Strengthening Inclusive Local Governance project in Iraq, funded by the German Federal Ministry for Economic Cooperation and Development, and supported by GIZ GmbH in Iraq. By the end of this video, you should be able to understand the impacts of climate change on critical infrastructure, differentiate between unprepared and resilient critical infrastructure systems, understand risk assessment fundamentals and risk-informed decision-making, identify steps for cost-effective resource allocation and risk management, and explore tools and protocols for infrastructure risk assessment. In this section, we will talk about the impacts of climate change on different infrastructure systems and briefly discuss the difference between unprepared and resilient critical infrastructure systems. What is the role of infrastructure in climate resilience and climate risk? When and if infrastructure fails, it can make worse the harms to a community. Clean water would no longer be available. If a power grid goes down, it can reduce access to cooling spaces. Conversely, it is also true that if critical infrastructure is resilient, it can help ensure a community is protected from climate hazards and climate events. Climate-ready infrastructure provides critical services before, during, and after climate events or disruptions, limits disruptions to businesses, ensures continuity of key services, such as health services, and can reduce harm to populations associated with climate hazards. Infrastructure is an important part. So, we need to provide each of these additional service areas. There are multiple and connected impacts of climate hazard. However, it's not just extreme events that we consider. There are many other impacts of climate hazards on infrastructure. Intense rainfall events are placing significant stress on infrastructure systems. These events can lead to loss or damage of roads, bridges, or airport assets, as well as transportation delays and safety risks. Increased stormwater runoff can overwhelm drainage systems, leading to flooding of underground facilities, water treatment and wastewater facilities, and accelerating infrastructure deterioration. Severe thunderstorms further compound these risks. They can trigger localized flooding, tornadoes, lightning strikes, and hail damage, resulting in power and communications outages, transportation disruptions, increased maintenance needs, and rising repair costs. Together, these impacts highlight the growing vulnerability of infrastructure to extreme rainfall and convective storms. In regions where snow and ice storms are a concern, climate change can increase safety and emergency risks, including transportation accidents, and it can limit access for emergency response services. Heavy snow loads raise the risk of roof and structural collapse, while ice buildup can trigger widespread power outages. These type of events also lead to higher snow removal costs, increased maintenance needs, a greater use of de-icing agents, as well as long-term infrastructure deterioration. Rising average temperatures and extreme heat can affect a range of infrastructure, including building envelopes, roads and runways, and power lines through the expansion, softening, and sagging. Increased cooling demand places additional stress on HVAC systems and electricity grids, raising the risk of power outages and accelerating infrastructure wear and aging. Long-term exposure to moisture, temperature fluctuations, or de-icing agents contributes to the deterioration of windows, cladding, and concrete. These weathering processes shorten the asset's lifespan, increase maintenance costs, and rehabilitation costs. Stronger winds can threaten the structural safety by damaging cladding or the exterior of buildings, windows, and other building components, and they can increase sway in very tall structures. Wind-borne debris heightens risks to people and property. Strong winds can also contribute to power outages, disrupt airport operations, strain emergency services, and make emergency response times longer, and they can increase inspection and maintenance requirements for a range of assets. In the next section, we'll take a look at the impacts of climate change on specific economic or infrastructure sectors. Climate change is increasingly stressing water infrastructure systems through multiple pathways. Urban stormwater networks and sewers are being overwhelmed by more intense and variable rainfall, requiring adaptation in design and capacity planning. Rising flood risks and sedimentation are degrading reservoir functions and dam operations, while extreme events can lead to catastrophic failures, as illustrated by costly dam breaches. Wastewater and stormwater facilities are also vulnerable to flooding and overflow, leading to untreated discharges that compromise water quality and public health. Collectively, these trends highlight the urgent need for climate resilient strategies in water and hydraulic infrastructure. Climate change is having impacts on the mining and natural resource sectors as well. The Bingham Canyon mine landslide highlights the vulnerability of large open-pit mining operations to slope instability. Climate-related changes in precipitation patterns, groundwater conditions, and temperature can further weaken slopes and increase failure risks. This underscores the need for climate-informed monitoring and risk management in mining infrastructure. In the electricity, power, and energy sectors, climate change is having impacts. Extreme heat can physically damage energy infrastructure, such as melting power cables or stressing transmission systems, while simultaneously driving up electricity demand and increasing the risk of outages during a heat wave. At the same time, climate change could significantly strain and even cripple power grids if systems are not adapted for more frequent extremes and cascading failures. In the transportation sector, we see a similar range of impacts due to climate change. Extreme heat can physically damage transportation infrastructure, leading to buckling roadways and rails, disrupting travel and supply chains. Wildfires and associated safety restrictions can compound these risks, showing how climate change threatens the reliability of land transport networks. Sea level rise can also have an impact on ports and coastal infrastructure. In the forestry and natural resource sectors, climate change is intensifying risks through more frequent and severe disturbances. Heavy rainfall and flooding can wash out access roads and damage routes to natural resource areas, while increased wildfire activity threatens forest management infrastructure, as well as workers and people. Wildfires also put associated infrastructure, such as access roads, power lines, and transmission corridors, at greater risk, undermining connectivity and operational resilience. Climate change is increasing stress on municipal and public infrastructure through extreme weather events. In British Columbia, heavy snow loads contributed to structural failures, including housing collapses. In Alberta, Canada, historic flooding inundated urban assets such as the Stampede Grounds and Arena, highlighting vulnerabilities in stormwater systems and flood defenses. These events underscore the importance of adapting municipal planning and infrastructure design for changing climate conditions. The agricultural sector is quite vulnerable to a range of different climate hazards and risks. Climate change is intensifying risks to agricultural infrastructure and operations as well. In the Prairies region of Canada, increasing drought severity and duration threaten irrigation systems, soils, and storage facilities. In other areas of the world, climate risks such as water availability, drought, and extreme weather can have an impact on agricultural productivity and safety of agricultural workers. Climate-driven extremes, drought, convective storms, and more underscore growing vulnerabilities of the agricultural landscape. This graph is from the Insurance Bureau of Australia. First, let's take a look at an unprepared or unresilient system. This is a community that hasn't really done much to prepare for extreme weather or climate events. When a climate event occurs, whether that's a wildfire, a drought, a typhoon, or an extreme rain event, the operational capacity is highly impacted. Roads might be closed, buildings and other infrastructure might be affected, or services could be disrupted. There is a subsequent long period of recovery as the community rebuilds and replaces damaged infrastructure and services, since this unprepared infrastructure has not planned in advance for potential climate events. The end result, in comparison to the unprepared community, some key characteristics.
In this section, we present information on risk, as well as risk assessment processes, standards, and frameworks. What is risk? The International Organization for Standardization, or ISO, publishes risk assessment frameworks, guides, and processes that are used globally. Their guides address risk in the context of public health, health and safety, enterprise risk management, and now climate change. ISO uses different definitions of risk depending on the context. In the area of safety, risk is a combination of the probability and severity of harm. In the area of enterprise risk, it is the effect of uncertainty on objectives. The first focuses on harm or loss, while the second recognizes that risks can have outcomes that are either positive or negative. In that first definition, adversity of outcomes is the focus, and positive outcomes are referred to as risk reductions or benefits. In that second definition, risk is an expression of the likelihood of an impact of an event with the potential to affect the achievement of an organization's objectives. Here, risk is two-sided. It includes both negative and positive outcomes and is concerned with both threats and opportunities. Risk assessment provides value to decision makers. That is why we undertake that activity. It provides clarity about who or what may be at risk, and it allows us to prioritize responses, If risk assessment is the identification and evaluation of risks, risk management is the set of activities that control for different risks, including the risk assessment process itself. And the risk management framework is the principles and guidelines that institutions, governments, or organizations have in place to implement and continually improve their risk management. ISO 31000 is a global standard for risk management. What you see here is the risk management framework, which sets out principles, a framework for management, and a process for risk assessment. According to ISO, managing risk is iterative and assists organizations in setting strategy, achieving objectives, and making informed decisions. Managing risk is part of governance and leadership and is fundamental to how the organization is managed at all levels. It contributes to the improvement of management systems. Managing risk is part of all activities associated with an organization and includes interaction with stakeholders. Managing risks considers the external and internal context of the organization, including human behavior and cultural factors. This slide shows the ISO 31000 risk management process. The ISO framework for risk assessment is not unique to climate risk. This framework and process is applied across multiple sectors. So what are the key steps in this diagram? Scoping. What is the geography, the time frame, the system for the analysis? Are you focused on corporate assets and operations, risks to departments within a government, or is it a citywide risk assessment? What problem or challenges are you trying to manage? This is all part of the scoping. The risk assessment itself includes the risk identification, risk analysis, and evaluation of risks. Risk treatment. This is the adaptation planning part. How do we control or manage the risk? Communication and monitoring are ongoing and well documented throughout the process. And implementation. Implementation is important because it supports assigning responsibility as a timeline to the implementation of measures that control risks. This framework can be modified to suit the needs of users, whether that's a government or a small business. In this section, we'll talk about how risk can or should be part of the decision-making process, and how we can make decisions that are informed by risk. What do we mean when we talk about commonly used terms, such as risk-based or risk-informed decision-making? Risk-based, this generally refers to activities or decisions where an estimate of the level of risk, or the level of risk reduction, or the cost effectiveness of risk reduction is explicitly considered in conducting the activity or in making decisions. Risk-informed. This is similar to risk-based, but often used when you are explicitly acknowledging that other factors, other than your measure of risk, are incorporated into the decision-making process. Risk-based decision-making is typically associated with the principle of proportionality in the application of risk control measures, an acknowledgement that zero risk is not a realistic goal, and an understanding that the probability of harm rather than the mere possibility will be duly considered. The unstated underlying quality is that decisions are made based on some combination of the level of risk, the level of risk reduction, and the cost effectiveness of risk reduction actions. Risk-based outcomes aren't exclusively reductions in the level of risk. Certainly, a desired outcome is reduction in the number and the severity of adverse outcomes, in other words, less risk. However, we can also increase our certainty about the level of risk at which a system is believed to be operating. So we can get less uncertainty in the level of risk. Both of these outcomes are beneficial, and both of these contribute or could be considered risk-based outcomes. Is the completion of a risk assessment all it takes to make a risk-informed decision? In this next couple of slides, we'll look at what goes into making risk-informed decisions. In the broader sense, making risk-informed decisions consistently within a government, whether at the national or the local level, or even within a specific department, relies on more than just the outcomes of the risk assessment. Risk assessments need three things. You need to have established foundational elements, you need a good risk management process, and you need robust risk assessments. What are the foundational elements? These include core matters of policy as it relates to public risk and its management. Ideally, these would be in place prior to day-to-day decisions regarding risk and would become part of the governance process. So what are some of these foundational elements that contribute to the ability to make risk-informed decisions? First are your principles. Have you established what are the common principles for managing and assessing risk? Inventories and data. What public harms or risks are within the mandate or scope? What are the possible options for managing the risk? Do you know what actions you can take? Do you have data and information that you can maintain to inform your risk decisions? And lastly, the ability to measure. Do you have a common scale to measure and compare consequences and risks? Can you analyze costs as well as the effectiveness of the actions that you take? Some of these foundational elements are critical to consistent risk-informed decision-making. The second element in risk-informed decisions are the risk management processes and frameworks that are established and followed. Institutions or governments can ask themselves, have we established the fundamental rationale for pursuing risk-informed decision-making as it relates to our mandate? How will the concepts of acceptable risk, tolerable risk, and unacceptable risk be defined? Have we explored what those risk tolerance levels are? And what is the role of external stakeholders in the risk assessment or the risk management process? And have we discussed and determined the role of risk communication in risk management? The final element, of course, is the risk assessment itself. Here, an appropriately scoped and rigorous methodology, such as the PIVC protocol, can provide information to help inform decision-making. Risk management can be driven by the pursuit of many possible objectives or virtues. When engaged in risk management, institutions need to consider what exactly they are pursuing. Are you looking to identify where the risk is? Are your actions targeted at reducing the largest individual or the largest population risk? Or are you going to where you can effectively reduce risk? Are you looking for the effectiveness of your actions? Or are you pursuing the most cost-effective risk reductions? Therefore, are you maximizing your overall risk reduction within a constrained budget? Or are you targeting a particular threshold? Do you know your level of risk tolerability in certain areas, and are you trying to simply get your risk below that acceptable or tolerable risk level? Lastly, you may be going after consistency. Are you trying to treat all risks and all people equitably and fairly? If you were to imagine you had three options. 1. A list of the top risks you can allocate resources to minimize or reduce risk. 2. A list of the largest risk reductions possible, and therefore you can allocate resources to those risk reductions. Or 3, a list of the most cost-effective risk reductions, and you can allocate resources to those risk reductions. Which of these sounds like the best approach? This is a question that governments and enterprises have to consider when pursuing and seeking out their risk management objectives. In managing risk, we can think about how we best allocate resources to maximize public benefit. Risks often can't be eliminated, and past a certain point, additional money, time, or resources may be better spent addressing other or different risks or taking different approaches. Part of the risk management challenge is determining how best to optimally allocate constrained or limited resources. On this side, and in the following slides, we'll try to illustrate why the cost-effectiveness principle is important in risk management. Each of the three charts show how additional resources or money allocated on the x-axis contributes to a reduction of loss on the y-axis. In the first curve on the top left, increasing inspection frequency produces an immediate benefit at low cost, but after a certain point, you no longer see public benefits. The relationship between the money spent and the amount of loss changes. Right? You'll see less benefit proportionally as you spend more. In the second curve, there's more of a linear relationship. As we spend more to reinforce the structure in this example, losses are proportionally reduced. In the final curve, it's more of a step change. There is no cost up until you make a decision to move an asset, at which point losses are effectively eliminated. In our scenario, we have a limited amount of money and we want to maximize the amount of public benefit and limit losses. At present, represented by the blue dots, we haven't allocated any resources or spent any money yet. Here, we are starting to allocate money to reduce losses through our adaptation actions. Some benefits are realized immediately. In our example, by increasing the frequency of inspections and making the current system stronger, we have reduced losses with a relatively low amount of total spending. Here, the cost effectiveness of additional inspections is about maximized. If we spend more on inspections, we're probably not going to see the same level of benefit that comes back. We're not going to be able to reduce losses much further. We can also do more by reducing losses through making the system stronger. This is the graph on the top right. So we spent a little bit more and we can see a proportional benefit in terms of the reduction of losses. We've reached a point here where, with the remaining budget, it makes sense to allocate resources to that bottom left chart. We make that one-time investment to move an asset and effectively eliminate a source of risk. Now, we've made that one-time investment on the bottom left to eliminate that source of risk. And with our remaining budget, we can do a bit more inspection and invest a bit more in making the existing system stronger until finally our losses are minimized and our risk control budget is fully spent. This example has helped us by showing that by understanding and considering the cost effectiveness of our risk reduction opportunities or our climate change adaptation actions, we can effectively allocate our available resources to minimize loss and maximize public benefit. If we don't consider that cost effectiveness, our residual losses and our risk may have been higher even after we used up the same amount of budget. Risk management frameworks and principles are important. If we have these risk management frameworks and principles in place, we can ensure that risks are compared and assessed fairly and consistently, that our allocation of resources and our resource allocation decisions are informed by the level of risk and the possibility to reduce that risk, and that our resource allocation decisions effectively minimize losses and maximize public benefit given the available resources. With the right information and frameworks, decision makers can make the best possible decisions about how to allocate their limited resources, while also reflecting the many realities and constraints that are part of governance. What are some key messages when it comes to risk-informed decision making? First, risk-based decisions are made when the estimated risk or risk reduction actions are considered in your decision making. Risk-informed means you incorporate other considerations. Risk-informed decisions require strong foundational elements, good risk management processes, and robust and credible risk assessments. Knowledge of climate risks help you allocate limited resources for maximum public benefit.
Infrastructure is affected by changing climate hazards and extremes. So how do we handle all of these things? What we use is, in terms of risk assessment, we want to consider
ISO has also published risk assessment guidelines directly related to climate risk. There are two listed on the left of this slide. One focuses on approaches to climate change adaptation, and one on guidelines for vulnerability, impact, and risk assessment. Both emerge from a common set of guiding principles. And these include flexibility. The organization or government continually reviews, responds, and adapts to new conditions, information, and methods and solutions as they emerge. It uses continuous learning and adaptive management processes, adopting an iterative approach to improve understanding, decision-making, and implementation processes. Another principle is mainstreaming. So climate change adaptation is most effective when it is integrated into an organization's processes, such as their policies, their plans, their procedures, as well as the implementation. Robustness. An organization or government uses appropriate methodological approaches and information sources that are relevant and lead to good and robust decision-making and climate change adaptation actions. Information about uncertainties is recognized as a valuable contribution to decision-making. The principle of subsidiarity. The organization empowers delivery of climate change adaptation at the level, scale, and degree of competence that will have the greatest effectiveness depending on the adaptation issue at hand. Systems thinking. Climate change adaptation processes include an understanding of cross-cutting or systemic issues of a government by examining internal and external interdependencies and linkages, for example, through cause and effect relationships. One more that I will mention is transparency. Reports and communications around climate change adaptation are based on an open, understandable, and appropriate presentation of information to all of the interested parties. Communication of risk is a key element in adaptation. How is climate risk assessment different than other forms of risk assessment? It is different from traditional risk assessment and management because climate change can shift the frequency and intensity of current risks. Flood events, high-intensity rainfall events, and storms begin to happen more frequently and with greater intensity. 2. There are slow onset climate change risks and opportunities, not solely hazard events that lead to emergencies. And there is a longer time horizon. Traditional risk assessment often focuses on current risks and present risk, but with climate change risk, we look at risks out to the 2050s or longer, and not just those immediate or present threats. Also, climate change risk assessment does often focus on the intersecting effects of non-climate stressors with climate change to provide information about the sensitivity of individuals or communities to that climate change, the ability of people or systems or communities to cope or adapt, and it integrates that knowledge to better understand the consequences and ultimately the level of risk that people or communities or systems are experiencing. There is a continuum within risk assessment, from narrative risk assessment to very quantitative or numbers and probabilities and statistics-based risk assessments. A narrative risk assessment may be based on interviews, workshops with experts and local knowledge holders, and it may be easier to understand and perform. Quantitative risk assessments rely on historical data as well as climate modeling. to provide numerical assessment of probability or outcomes or the benefits of risk controls. Flood forecasting may involve integrating hydrological and climate data as well as spatial data. You can develop and integrate depth damage curves and so on. And this can provide information on probabilities, consequences of flood events, and can provide numerical cost-benefit analysis when it comes to risk controls. Quantitative analysis can be complex and data-intensive. Many risk assessments, including climate change risk assessments, often fall somewhere in the middle, where expert and local knowledge is part of the process, but there is a quantitative element. So you may have quantitative analysis or scoring methodologies that are used to rank risks. The PIVC methodology is an example of a semi-quantitative methodology. Here are some recommendations to get the most out of your risk assessment activities. First, begin with the end in mind. Always know specifically what you will use the information for. What level of detail is needed to enable your decision making? Envision the ideal outputs from a risk assessment process and do not simply reproduce a report. 2. Equip yourself with the right tools. Identify and select an appropriate framework or process that enables the scale of your assessment. You may want to use the PIVC tool to do an analysis for certain systems, but other tools might be appropriate in other situations. 3. Always enable implementation of the results. Even at a very high level, consider what it is and what it will take to implement your results. Avoid unclear risks, opportunities, or resilience building actions. Identify lead and support roles, timing, and costs if possible. Climate risk assessment is about pricing risks from climate change based on projections of future climate and the likelihood and consequences of impacts occurring. There are many different frameworks and options for risk assessment. Select the tools and the approach that meet your needs. Engaging staff and experts and community is essential to a successful risk assessment process. And keep implementation in mind at all points.
PIVC stands for The PIVC protocol is a well-established. Where can PIVC be used? The unique and useful aspect. The PIVC program provides. So we can use the PIVC green. There are some noteworthy and important features. While it was developed in Canada, as you can see,